Hey, g'day, it's Prezzo here, back in the shop. Thanks for dropping by. This is a DIY sandblasting gun. It's made from a casting with a cord hole inside it. And this is a very traditional way of casting metal components. But the technique that I use to do this is a little bit different, and that's what I want to show you today. Now this is the core box that I use to make the rigid sand core, which creates the cavity inside this gun. And this was the first version of this that I tried, and it sort of worked, but it was really hard to get the rigid core out of the core box without breaking it, because it's only made of sand and a binder. And I had a lot of really good suggestions about how to make this an easier process, and I'm trying to take on board some of those comments and try and make the process a bit easier for me. Now, the other thing is that traditionally you would use a mix of sand and sodium silicate hardened with CO2 gas to make the core, and I tried that and it sort of worked, but I came up with an even, what I think is an easier solution and a more reliable solution, and that is to use sand and epoxy resin. Now this is not my idea. I must give credit here to a YouTube channel called LUCKYGEN 1001. He does some amazing stuff with his home foundry. Working with cast iron at home, which is something that scares the living daylights out of me, but he seems to get excellent results without killing himself, which is amazing. But what I want to do today is to show you how I've improved making these 3D printed core boxes, and also the process of making that sand and epoxy resin core. So here is the new version of that. Now this time the core box is actually made in 4 parts. Once again, not my idea. Somebody suggested this to me and I thought it was a really good idea. It's no more difficult to 3D print this. And the other thing is that this top half, has an extra break in it. Not all the way through, only partial. So that you can flex that section there, and that makes it a bit easier to de-shell the core as you take it out of the mold. Now, the process for doing this was just a matter of printing in a gap in that area there, and it's easy for me to show you this on the computer, so let's go and have a look. Okay, here is the part in Autodesk Inventor. Now if you use Autodesk Fusion or some other CAD program, you can do essentially the same thing, but in this case I just want to show you what the part looks like. So there is a feature here, and if I turn off all the other features, alright, that's the part that I actually made when I subtracted the model of the core from the core box, and I'll show you how I did that later. But when I first 3D printed this, I thought about it and I thought, well, it'd be nice if you could actually flex this part away from the core, and that makes it easier to separate the core. And then I decided that, in fact somebody else suggested to me, that it would be a good idea to actually put a split in it. So here is the split, and if I zoom in there you'll see that the split itself is 0.4 of a millimeter wide. It finishes with a circular feature up here so that it will flex without cracking through. And when I initially did this, I used a gap of 0.2 of a millimeter between these two edges, and I found that the 3D printer was fusing it together. At 0.4 it basically separates quite easily, and it's quite easy to bend apart. So that's the part that I just showed you in the video. Let's have a look at what it looks like when you do it in Autodesk Fusion. Here is the beginning of the process that I use in Fusion. Now this is the actual core. I model the core up first, and then I import that into Autodesk Fusion, and I create a second body around that. So this area here, you can see in blue on the top there, that's going to be what essentially becomes the core box. Now at the moment the core itself is just sitting over the top of that, and there's no hollow space. If I turn off the core, let's see, there you go. So that is just a solid block of material, as if you were to 3D print that particular part. If we turn the core back on again, so it's just sitting there along the top plane of that part. Now there is a command in Autodesk Fusion called combine. Okay, now when you combine two bodies, you can actually literally join two bodies together, two separate entities, or you can subtract one from the other. So if I turn that on down here, now you can see that there is actually a hollow space where the core used to be. So let's turn the core off. There's the profile of the core, or the imprint for the core. And the next thing we need to do is to split that half of the core box again into making 2/4. And there's a process, once again in Fusion, called split body. Where is it? Modify. And okay, split body, there it is there. And if you create a sketch or a plane, you can split that into 2 parts. So let's turn that on. And that's the quarter that I have left with the imprint of that section of the core. Now we still need to create that slit through the top of that core part, so we'll have a look at that. So there's the slit in place, and once again 0.4 millimeter wide. It's got the circular stop at the end there. And basically that's it. So you can then save that as an STL, print that on your 3D printer. And just one thing though, when you are printing in whatever software you use for your 3D printer, it's a good idea to scale this part by about 2%. That takes into account shrinkage in the PLA as it cools, and also you can sort of factor in the shrinkage in the material that you're going to cast in. So aluminium has a shrinkage rate around about 1 or 2%. So it would be a good idea to do that, especially if you haven't left a lot of machining allowance. Anyway, let's head back down to the shop now and we'll have a look at the process of filling the core box with the sand and epoxy mix. Okay, so here's our half of the core box. I'll just zero the scales there and we'll pour the sand in. Should have got a smaller container. Alright, that's not real neat, but we just want to get a rough idea. Okay, so we got 50 grams of sand for half the core, so we'll double that to 100 and then I'll add another 20 just to be sure. Then we can work out our resin to sand mix. I'm going to use about 3 to 4%. Now I've heard ratios up as high as 8% and as low as 2. I think you know, you run into issues if you have too much resin because it may stick to the PLA core box more readily. You may also get issues with the resin burning out or giving off lots and lots of gas as the hot metal surrounds it. And I believe the correct term for that is called PYROLIZING. I desperately want to use that word next time I'm at a barbecue. But pyrolizing is a process where something will burn in the absence of air. But let's go for, say 3 or 4%, see how that works out. Alright, so as you can see, what I need to do now is to mix up my sand and resin using a ratio of around about 4% resin. Now, just so you don't get confused, I'm doing another sort of unrelated project which relates to this thing. See, you didn't guess what it is. That's going to be a project coming up later. But I need to make up a core, actually I need to make 2 cores for that project. And I've got the core box for that one. It's quite small, but I've had to incorporate the correct amount of sand for this one as well. So I figured it out. I need 120 grams of sand to fill this core box, and the rest will be for the smaller one. My resin is going to be mixed at a ratio of 2 to 1. Now I understand you can use just about any sort of epoxy resin for doing this. The one that I have is a clear epoxy used for wood turners and woodworking projects, but just about anything will do. So what I need is a total of 6 grams, giving me the ratio of 4%. It's going to be a bit awkward, so I want 4 grams of this stuff. It's a very, very small amount of resin. So 2 grams of the other part. Okay, I'll give that a good stir and we'll mix it in with the sand. And I'm sort of guessing that you could use any sort of thermosetting resin, so even polyester resin used for fiberglassing, that would probably work. So I've got my pre-measured sand in here, and this is just ordinary beach sand, nothing special. And it sort of looks like just slightly damp sand at this step. It does need to be thoroughly mixed. You don't want to get any sort of lumps of liquid resin in it. I'll get some gloves on and we'll get this packed into the core box. When I first started doing this, I actually assembled the whole core box and I was trying to poke the sand in through the openings at either end, and realised later on that that was just a lot of hard work. I'm going to just sort of fill both halves as much as I can and then we'll put them together. I'm just going to put a little clamp on this, just temporarily. So that sort of gets the bulk of the sand into the core box, and then you can sort of compress it from the ends later on when the whole thing goes together. Okay, so the only trick with this now is getting the two halves together without spilling everything, and I've got some dowel holes. There's two dowel holes, two dowel pins, and I need to make sure that there's no sand in those little holes there. So I'm just going to get something to clean that out, and then we'll get the two halves together. Okay, I've got a sort of a bad feeling about this. I think it's all going to spill out. Let's see. Ah, the clamp's in the way. Okay, it's not bad. Now I'm just going to hold all of this together with a couple of rubber bands, and then we'll, compact it from the three openings that we've got. Okay, so what we need to do now is just get a dowel and start compacting all that sand that's in there. Surprising actually, when you do get it fully filled up, you can sort of feel that it won't compress anymore. So that's taking care of the leg that goes down to the main body, and we'll just do these two ends. Okay, that seems to be pretty good now. I can feel when I press on the ends, all three ends there, it's quite solid. If you overdo it, you can feel the whole core box starting to expand. Before I let this set, I'm going to run a wire through from one end to the other as a vent for the core, and I'll run a vent wire up through this end as well. When I made the first core that I used, I actually left the wire in place as a reinforcement, but with this core box I'm hoping I won't need that, so we're just going to leave the hole through. And I believe that the idea of that is that any gases that build up inside the core can vent out through those holes, and then if you provide a hole from the end of the core up through the cope, that will also allow gases to escape from the sand mould itself. So we'll do that, but just while I've got this resin wet, I'm going to do the other core box. Now this one is an odd shaped one. It's got quite a deep cavity in it, and I'm going to do it in 4 quarters again. But this one, it was really hard to sand inside that, so I sprayed that with a silicone spray lube, and I'm hoping that that's going to be enough. But we'll get that one filled, and I won't show all of that now because it's for a different project, but we'll get that one filled up, and then we'll come back tomorrow and we'll de-shell our core. Okay, it's 24 hours later. Let's get all the rubber bands and tape off this, see if it comes apart. I sort of checked a little bit of sand that I had left over, and it's cured quite well. Seems quite rigid, so that mix of 4% resin seems to work quite well. I was a bit sort of dubious when I started packing in it. It seemed really dry and crumbly, but it's cured quite well. Now this time when I printed these core boxes, I actually printed in like a 45-degree chamfer around these edges here, just to make it easier to get a screwdriver blade or a knife blade in there to separate it. When I did the first one I didn't do that, and it was really hard to get a knife in there to separate the parts. So let's see how we go this time. Well, that's promising. So in theory, you should be able to just sort of flex that. Yeah, there it goes. Alright, that's good. So let's see if we can do the other small one. So, I don't know if you, there you can go, you can see that, that's the core flexing, or sorry, the core box flexing. And it just sort of pops, oh, look at that, how easy is that? Now, there's a little bit more contact area with this one. Now this time I didn't use any dowel pins. That's good. This always seems to be the most challenging part. Actually, I did use dowel pins. Sorry, I forgot. Just want to just tap that off. That did it. Isn't that the sexiest thing you've ever seen in your whole life? Oh, I'm really pleased with that. That gave me a lot of grief getting that one part off, but yeah, it was just a matter of going around just cutting off the flash line and just giving it a tap, and it released quite nicely. So looks like using that beeswax in there seems to have made that release quite nicely. Surface finish on that is excellent. I can just do a bit of a clean up on that flash line with some glass paper, just or scrape that maybe. Yeah, that just scrapes off quite nicely. Alright, so I've got to be really careful with that now and get it into the mould and see if we can cast ourselves a beautiful aluminium cast DIY blast gun. And here is the pattern, and can you see the very, very futuristic lightning bolts? And wait till you see this one when it's in its finished form. And I'm not going to show you all the machining on this one. I'm just going to get it done. I'll show you when it's done.